Okay, everyone, here we are, lesson 3 on halide ions and conc sulphuric. And here's the diagram that I drew last time, and here's just the first little correction here, because I've looked it up. Brown fumes, bromine, brown fumes or brown gas. So what we're looking at now is using this diagram. It's really, really important for the reactions of solid sodium halides, it's important, the solid bit, and concentrated H2SO4. And it's to show, these are reactions to show the reducing ability of the halides. I've got a wobbly camera set up again. Let's have a little look if I can. A bit better. Okay. First thing to do then, as all my drawings from the last video, I'm going to start off by just redrawing the diagram. If you can draw this, you're nearly there. You can't use it. You won't. You know, if we're talking about using this diagram, if you can't even draw the diagram, you haven't got a chance. So it's all very well. You can sit there going, I don't get it. Well, first of all, learn this. Then you'll have a chance of getting it. So this one, I'll just start off. This is chloride or fluoride, the worst reducing agents. They don't actually reduce H2SO4. Bromide and iodide. Bromide does 2 things to H2SO4. Iodide does 1, 2, 3, 4 things. Well, what's the first thing that all of these 3 do? Well, the solid sodium halide will react with H2SO4 to make NaHSO4 plus HX. So that's HI, HBr, or HCl, which is misty fumes. Sometimes you can see this equation balanced with Na2SO4. But I just want you to learn this one way. Next thing they do, watch this. You go SO2, SO2. You can write S, H2S. They are the sulfur products. In here you write Br2, in here you write I2, in here you write I2, and in here you write I2. Eggy smell, yellow solid, choking gas, black solid, brown gas. So as I say, apologies for any confusion. I'm just going to do an example now of what a question might say. Alright, the question might say, when solid sodium iodide is reacted with H2SO4, a yellow solid is produced. Write an equation for this. Okay, you follow that question? When solid sodium iodide is reacted with concentrated H2SO4, a yellow solid is produced. So you've just got to go, all right, where's the yellow solid on this diagram? And you go, they must be asking me about this box. Did you follow that? So the clues in the question were solid sodium iodide and conc H2SO4. Then they say yellow solid. So that is the box they are talking about. So what they want is an equation for this box. And you might look at that and go, I haven't got a clue. How do I write an equation for that box? Well, what you do, because you know this is redox, you can do 2 half equations. You know that the S is formed from H2SO4 originally, and you know that the I2 is formed from I-. So what we do, if we know what the products in the box are and where they came from, we can write an overall equation. And I'm going to do that now. The yellow solid is S, and you also make some I2. The S comes from H2SO4, the I2 comes from I-. What we do here, 4 oxygens balanced with 4 waters, 4 H2Os. 8 H plus and 2 H plus, so we're going to need 6 H pluses over there. And we will also therefore need 6 electrons on this side. I minuses, you're going to need 2 I minuses, and you will make 2 E minuses on this side. These 2 equations, these 2 half equations, are now balanced. The half equations are balanced. The final thing to do then, there are 6 electrons here and there are 2 electrons in this half equation, so we're going to multiply everything by 3 in this bottom half equation. And to do that, so we're going to get both half equations to equal 6 electrons. So that will be 6 of these, 3 of these, and 6 of these. Now all I need to do is join these 2 equations together. 6H plus H2SO4 plus 6I minus arrow, that's these three, will make sulfur, which is the yellow solid, plus 3 I2s, which is a black solid, plus 4 H2Os. The electrons and the electrons will cancel. So the equation, just the clues we got from the equation are conc H2SO4 and iodide. It said yellow solid, and all I did, if I learn that sulfur and iodine are formed, I can come up with this equation. I have seen teachers teach this as learn an equation. You do not need to learn an equation, you just need to know the products. So a separate one might say a brown gas or a brown fumes or whatever was produced along with a choking gas when a sodium halide was reacted with concentrated H2SO4. And the examiner might say, what sodium halide was used? So you're now looking for a choking gas and a brown gas. Well, choking gas is clue for SO2 and a brown gas is Br2. So they're asking you about this. So the sodium halide would be NaBr. You know this is the bromide observations. If it asked you to write an equation, you would say, right, well, the brown gas is Br2. That must be formed from Br minus. And the choking gas is SO2. So I'm just writing out that little box up here, which must come from H2SO4. 2 of these, 2 E minuses. H2SO4, 1, 2 oxygens here, 4 oxygens here. We need 2 H2Os. 1, 2, 3, 4 hydrogens. 1, 2, 3, 4 hydrogens. 2 E minuses. 2 electrons there, 2 electrons there. So the overall equation is, you just join these together. 2 Br minuses, 2 bromide ions, plus H2SO4 plus 2H plus, U and U, make Br2, there's your brown gas, running out of space again, I do need a wider angle on my camera, plus SO2, brown gas, choking gas, plus 2H2O, just gone off the screen there. Alright. Is this a redox reaction? Of course it's a redox reaction. -1, 0. The bromide has given up its extra electron. H2SO4 plus 6 plus 4. It's redox. So, that's just showing you an example. I promise you that all you need to know is this diagram, and then from this diagram, it's just turning these two products into an overall equation. This bottom equation you could just be asked for in an exam, and you need to realise that this one is not redox. So what I'm going to do now, it's a bit of a spoiler alert, but I'm going to go to the questions that you've been given on this, and I want to show you how they work with this diagram. So if you want to try these questions firstly on your own, feel free. But I'm going to have a little look at them now. I'm not going to go through all of them. All right, that might come if you request that from me later on. I can look through all of them. All right, so what I'm going to start off with is this multi-choice. So what statement is correct about the reaction of conc sulphuric acid? So that's the clue for me already. I'm thinking, hang on, is this going to be about halide ions and solid sodium bromide? All right, so it is. It's all about that. So straight away I'm thinking, diagram, solid sodium bromide. It's asking me about these two boxes there. Should not have used black. That's just ruined. Okay, it's asking me about these two boxes here. All right, so I know what's in these boxes before I look at the question. I've got SO2, Br2, and across the bottom I'm also forming NaHSO4 and HBr. Okay, so that's what bromide does. Which statement is correct about the reaction between conc sulphuric and solid sodium bromide? Bromide ions are reduced. Well, I know that bromide ions go from Br minus to Br2. 2 Br minus, 2 E minus. Bromide ions are reduced. Well, that's going from -1 to 0. The oxidation number is going up. No, that's oxidized because the bromide ions are losing electrons. Bromide ions lost their electrons. That's oxidation because oxidation is loss. It's not you. hydrogen bromide and sulfur are formed. No, sulfur is formed here with iodide, so it's not you. Sulphuric acid acts as an oxidizing agent. Well, if you think about this, this whole diagram is showing how good bromide, iodide and chloride are as reducing agents. So therefore, the sulphuric acid in here is the oxidizing agent. That is the answer. This experiment is to show how good a reducing agent the halides are. So in this experiment, the H2SO4 is acting as the oxidizing agent. Let's just check that the bottom one isn't right. Bromine and hydrogen sulfide are formed. Well, bromine is formed, but not hydrogen sulfide. Hydrogen sulfide is the eggy smell that is formed with iodide. So even if you didn't quite get that it was why C is the correct answer, which I hope you do, you know that it's not A, B or D. And that all comes from using this diagram. All right. Solid sodium iodide, conc sulphuric acid. Here's your diagram again. Alright, which species is not produced by a redox reaction between iodide and conc sulphuric acid? So there's iodide, and here are the products. We've got H2S, S, SO2, and HI. Misty fumes, SO2, S, and H2S. And you're also forming I2, I2, and I2. Other products down here are NaHSO4, which I did tell you can also be Na2SO4 in some situations. Okay, that's my iodide column because I've learnt it. Which is not produced. Well, firstly, Na2SO4. You might be thinking with that one anyway, well, I don't really know that. I know NaHSO4, so maybe you're already thinking that. Let's just have a look at the others. H2S. H2S is produced. S is produced. SO2 is produced. So it must be this. And you think, well, even if you had learned that Na2SO4 is produced, remember that this bottom one is not redox, and it's not produced by a redox. So it's definitely A. All right then, we go on to question 3. So for each of the following reactions, select from the list below, and this is the list below, the formula of a sodium halide that would react as described. So you've got NaF, NaCl, NaBr, and NaI, which fit into the diagram above, like that. Notice on all of these equations that I write, the Na just becomes a spectator ion. I can ignore the sodium. Right, each formula may be selected once, more than once, or not at all. This sodium halide is a white solid. Now, here's a little thing about them. They're all white solids. All of them. Every single sodium halide is a white solid. And it reacts with conc sulphuric acid to give a brown gas. Right, brown gas. Brown gas exists in here. That's the brown gas. So the sodium halide must be NaBr. See, there's no doubt about it if you know this diagram. If it had said forms a black solid or an eggy smell, you'd have written NaI, but it didn't. B is about silver nitrate. So I'm going to leave that because that's from a previous topic. I do want to go through it anyway. Silver nitrate, AgNO3. So it's not to do with this topic, but hopefully you remember chloride, bromide, iodide, with silver, Ag+. If you have a solution of the sodium halide, you get AgCl, AgBr, AgI, white, cream, yellow. When a solution of this sodium halide is mixed with sodium nitrate solution, no precipitate is formed, but that gives a white, a cream and a yellow, which means that the only possible is NaF. That gives no precipitate. All right, and I'll look at question C. When this solid sodium halide reacts with conc sulphuric acid, the mixture remains white and steamy fumes are given off. All right, so there's no black made, there's no brown made. It remains white and steamy fumes. Now, I've read this normally as misty fumes. So the only observation is misty fumes are given off. All right. Hopefully you realize that that must be this box only, so you're dealing with NaF or NaCl. All right. A more advanced question then. There's another question at the top there, but whatever. Iodide ions. Iodide ions can reduce sulphuric acid, H2SO4. Yes, they can. They can reduce concentrated sulphuric acid when bonded to sodium ions as a solid sodium iodide. Name 3 reduction products and give the oxidation state of sulfur in each of these products. Okay. This term reduction products can catch you out, but anyway, we're dealing with iodide, so we're dealing with this column. You remember what this column is? You've got NaI, NaHSO4, I2SO2, I2S, I2, and H2S. Okay. Name 3 reduction products. Now, the reduction products are the products that are formed when the reduction has happened. So there are lots of products here, and the question is, are you going to write SO2S and H2S, or are you going to write I2? Well, it's the sulfur product, and I'll prove that in a second. Right, name the 3 reduction products. The reduction products are H2S, but it says name, so you'd write hydrogen sulfide, S, which is sulfur, and SO2, which is sulfur dioxide. It says give the oxidation state. Remember, you would have to name them. You wouldn't get the marks for this. Oxidation state, well, that's +1 each. This must be -2, -2, 0, -2, -4, +4. Why are these called reduction products? Well, because they've come from H2SO4, and if you turn H2SO4 into H2S, it goes from +6 oxidation state, the sulfur, into -2. The oxidation state has been reduced, made more negative. That is a reduction. So the reduction product is where you have reduction and it's the product. That's the reactants, that's the product. The reduction product is what is produced after a reduction has happened. But do you see how this question now, if you see the clues in the question, it's about sulphuric acid and halides, you draw this diagram, if you know this diagram, you can get quick marks. The next little question here, describe how observations of the reaction between solid potassium iodide, so don't freak out about potassium iodide, sodium iodide, the potassium and the sodium are spectator ions, and conc sulphuric acid, H2SO4, can be used to indicate the presence of any 2 of these reaction products. Alright, so describe how observations. In other words, what they're asking you is, what do you see? What observations will prove that these things are produced? Alright, can you remember the observations? Eggy smell, yellow solid, choking gas. Alright? You are not allowed to write about these as reduction products, because remember this first row. So if you write misty fumes, you'll get that question wrong. Write half equations to show how 2 of these products are formed by the reduction of sulphuric acid. Alright, well I'm going to do eggy smell. Eggy smell is formed from H2SO4. You can then go 4H2O, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you're going to need 8 H pluses and 8 E minuses. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2. I'm just thinking, did I get one wrong on the last page? Did I put 6 for that? I'm thinking back in time to a last video. Bear with me as I worry whether I've made a mistake earlier on. Oh no, that was the sulfur one. Yeah, cool. H2SO4, 4H2O. There's a half equation showing how it's formed from sulphuric acid. How's the other product formed? You could do the same for sulfur. You could write a half equation, do water, do H+. Write an equation for the reaction that occurs when chlorine is added to cold water. That's not to do with this topic, is it? That's not to do with halide ions. I'm just going to sneeze. Am I going to sneeze? No, I'm not going to sneeze. Chlorine is added to cold water. This is a reaction that I told you to learn. It's about disproportionation. You had to learn it. Cl2 plus H2O. I can't remember it. HClO. Oh, I can't remember it. Literally can't remember it. H2O? Nah, that's not right. HCl. HCl. I think that's it. Can't quite remember. Gonna check the mark scheme. Do you see what the thing is though? If I was going into an exam and I didn't know that, I'd have to blooming well revise it, wouldn't I? What question is it? Question 4. This is like from the depths of my memory. I'm just trying to show you that I'm not cheating here. Oh yeah. There's HCl. I wrote HClO, same thing. Cool. I remembered it. What else? State whether or not the water is oxidized and explain your answer. Whether or not the water is oxidized. Well, the water here has oxygen in -2 and hydrogen in +1, and at the end the oxygen is still -2 and the hydrogen is +1. No, the water is not oxidized because the oxygen and the hydrogen have the same oxidation state on the left and the right. Something's happened to the water, it's been split up, but it hasn't been oxidized, it hasn't been reduced. This is an example of chlorine, where both the chlorine atoms in here are 0. One of them ends up as +1 and one of them ends up as -1. This is from a topic that you did last week or just before half term, and that's called disproportionation. All right. Straight away from this, which species is the best reducing agent? We've just been talking about reducing agents. Halide ions make good reducing agents. All right. So there you go. I'm not telling you the answer to that because it's straight off that diagram. Which of the halide ions is the best reducing agent? Okay, finally, just another thing then. How does this work? Sodium bromide. So question 8. Sodium bromide, NaBr, reacts with conc sulphuric acid, H2SO4. So we're dealing with our little diagram again in a different way to sodium chloride. Oh, no, it does, because I know this diagram. Sodium bromide. So it's not asking me about iodide. Sodium bromide reacts with conc sulphuric acid in a different way. Well, have a look at this diagram. This one and this one are the same way, so it must be asking me about that. Different way. And what's in this box? We've got an SO2 and a Br2. Write an equation for this reaction of sodium bromide. It's asking me about this equation. Ah, right, so it hasn't given me room to work it out, but I know that the H2SO4 turns into SO2. The Br minus turns into Br2. I'm not worried that it doesn't give me space. I could even work it out over here. 2E minus is there. 2 H2Os. 2H plus. 2E minus. Right, so it looks like I've got 2 H pluses plus 2 Br minuses. That's that one and that one. Plus H2SO4 makes SO2 plus Br2 plus 2H2O. So in an exam, I'd have done my working over to the side so I could fit that in. Explain how it reacts, why it reacts differently to chloride ions. All right, so why does bromide do this one and chloride only does this one? Right, chloride is smaller. Remember 2 videos ago, is smaller than bromide. Here's chloride with its extra electron. Here's bromide with its extra electron. Chloride is smaller than bromide, so chloride holds onto its outer electrons more strongly, so bromide releases its outer electrons more easily, or it is more easily oxidized. Alright, that's hard that, but it's the point of this whole exercise. If you can remember how to use, so can you memorize this? Do you know how to use this? And then the final thing is going full circle. And can you remember why we're using it? We're using it to explain what I said in that first video, that chloride is a terrible reducing agent because it doesn't want to let go of its extra electron. Bromide can reduce stuff. It can reduce sulphuric acid a bit. Iodide is the best reducing agent. It releases this extra electron so easily. It just reduces anything that you put it with, and particularly concentrated sulphuric acid. All right. A colourless solution. contains sodium chloride and sodium bromide. Right then, if it's to do with solutions, it's not to do with this diagram, because this diagram is all to do with solid sodium chloride and sodium bromide, so it's not that diagram. Sodium chloride and sodium bromide, as is silver nitrate, and any other reagents of your choice, develop a procedure to prepare a pure sample of silver bromide from this mixture. Alright, so anyway, I'll help you a little bit with this. Chloride and bromide, if you add silver to them, what you get AgCl, you get AgBr. Do you know that this is white and this is cream? Yeah, can you remember the follow-on reactions that you add? What do you add here to tell the difference between the two? Then what could you do after that to get the AgBr out? I'll leave that to you. That's a good question, though. Anyway, I hope what you're finding is that it's demystifying this topic a little bit. I want you to learn that diagram, work your way through these questions on your own. You'll see a variety of answers in the mark scheme that look sort of like yours, maybe a little bit different, like they might have spectator ions in or missing or whatever it might be. If you learn it the way I've told you, you will get the marks. Okay, see if I can work any others out here. Any other good ones to go through? Balancing half equations, halogens. Solid sodium halides react with conc sulphuric acid, so we know straight away we're dealing with this diagram. Okay. Solid sodium halides react with conc sulphuric acid. A sample of solid sodium iodide, so we're dealing with these, reacts with conc sulphuric acid. A black solid forms, yes, that's the I2, and hydrogen sulfide gas, H2S, is formed, which is up here, H2S. Write a half equation for the reaction of sulfuric acid to form hydrogen sulfide, H2S, and then you write H2SO4, and then you balance it with waters and hydrogens and things. Write a half equation for the formation of the black solid. The black solid is I2, and it comes from I minus, so you do that and you do that. Use your answers to write an overall equation. Well, you multiply one of these to make the electrons the same and join them together. What is the role of the sulfuric acid in the reaction with sodium iodide? Well, you know that the iodide is the reducing agent, so the sulfuric acid must be the oxidizing agent. Write an equation for the reaction of conc sulfuric acid with solid sodium fluoride. Alright, so you might look at this diagram and go, where's fluoride again? Well, fluoride is here and chloride is here, so the equation must be that one that I told you to learn across the bottom there. Alright, so you go sodium fluoride plus H2SO4, and you would write the two products on this side, and you've got the mark. Now, I'm sure they sometimes put a different one in the mark scheme at the back, but that doesn't bother me. Learn that one that I told you, and you'll be fine. I'm just trying to find that mark scheme now. What question are we on? What question am I on? What's the next question? Question 9. Where are you? Where are you? I have lost it. Question 9. 9C. Huh. Is it 9? Oh no, not 9. 10? B, C, sorry, 10. Cool. I'm good at looking at stuff. Question 10, C. Part 5. Taking me ages, this. There. There's the one that I told you to learn, isn't it? Cool. I'm done. I hope it's clear that you need to learn this, number 1. Then it's clear that you've got to learn this equation on the bottom and know that it's not redox. And then I hope it's abundantly clear that you have to be able to write half equations and join them together. So that's what you were doing 3 weeks ago, and this is one of the reasons why. If you just know this equation across the bottom, SO2, SO2, Br2, I2, S, I2, H2S, and I2, and you can write a little half equation for all of them, you have the ability to write an equation for any one of these boxes, and they are all the equations you need to be able to write. So if you didn't do it properly 2 weeks ago and learn how to write half equations, here's another chance to get it right, but hopefully you did learn it well, and this is going to be straightforward. All right. Most people in the country hate this topic and do really badly at it. I hope that this diagram is going to be a bit of a lifesaver for you. So before I go, I'll just bring that diagram back up to remind you what it looks like. And there it is in all its glory, with that little mistake there. All right, done. Oops.